Your ability to extend sequences is something that is commonly tested on the ACT math exam. The two most common types of sequences that you will encounter are arithmetic sequences and geometric sequences. In this video, we'll review both. An arithmetic sequence is a progression of numbers where the difference between each successive term is a constant. So let's look at the first example. What is the common difference in the following sequence? 7, 4, 1, negative 2, negative 5. So let's subtract the second term and the first term. We'll get 4 minus 7 is equal to negative 3. So negative 3 is the common difference. You can double check that by taking the fourth term and the third term, the fifth term and the fourth term, or anything like that. You know this is an arithmetic sequence because negative 3 is the common difference between successive numbers. For another example, what is the common difference in the following sequence? 3.5, 7.5, 11.5, 15.5, 19.5. So if we subtract any term and its previous term, you'll notice that the common difference is 4. Now what about extending sequences? Well, we can calculate any term in an arithmetic sequence by using the rule x sub n is equal to a plus d times n minus 1, where a represents the first term and d represents the common difference. So let's do the example. What is the 23rd term in the following sequence? Negative 13, negative 10, negative 7, negative 4, negative 1. We can approach this in two ways. We can simply extend the sequence one by one until we reach the 23rd term. That may take a while. Or we can simply use that formula. So let's use the formula. So we have x sub 23 is equal to a, which is the first term, or negative 13, plus d, which is the common difference, which is 3, times n minus 1, n being 23, and then subtracting 1, we get 22. When we calculate that all out, we get 53. So 53 is the 23rd term in that sequence. You can double check that by simply writing out all of the terms until you reach the 23rd term and make sure they match up. Sometimes on the ACT math test, you'll be given a question that looks almost identical to this. Sometimes it'd actually be faster if you write out all of the terms. Let's say they said, well, it's the 7th term. Well, that'll be a lot easier than writing out an entire formula. Other times, they give you a ridiculous term, such as the 107th term, or something like that, in which case, knowing the formula would be a much better way to solve this type of problem. Let's look next at geometric sequences. A geometric sequence is a progression of numbers where each term is found by multiplying the previous term by a constant called the common ratio. Let's find the common ratio in a couple of sequences. So what is the common ratio in the sequence 5, 15, 45, 135, 405? Well, if you take 15 and divide it by 5, so you take the second term and divide it by the first, you'll notice that you get the answer of 3. Likewise, if you take the third term divided by the second term, so 45 divided by 15, you also get 3. So the common ratio here is 3. In the next example, what is the common ratio in the following sequence? Negative 0.5, 0.25, negative 0.125, and so on and so forth. You have a slightly different type of scenario. You're alternating negative and positive numbers. So the common ratio is going to be negative, because every time you multiply by a negative number, you get something with the opposite sign. So you can take 0.25 and divide it by negative 0.5, and you'll end up getting a common ratio of negative 1/2, or negative 0.5. You can take any number in the sequence and divide it by the previous one, and you'll still get negative 1/2. Like with arithmetic sequences, we can calculate any term in a geometric sequence using a simple rule. That rule is x sub n equals a times r to the n minus 1 power, where a is equal to the first term and r is equal to the common ratio. So let's figure out the 11th term in the following sequence: 3, 9, 27, 81, 243. So first, we'll find the common ratio, which is 3 by looking at it. So let's plug that in to our equation. So x sub 11 is equal to a, which is the first term, so 3, times r, which is also 3, to the n minus 1 power. So 11 minus 1 is 10. And when we do that, we should probably get a very large number. So that equals 177,147.